Astrium, Germany inspection on arrival. After an 18-hour drive, a key component of the Milde Pathfinder experiment arrives at the satellite architect Astrium on Lake Constance. Here, together with many other components, the optical bench, made in Glasgow, will be assembled into the core of the Milde Pathfinder experiment.
Of course, something which is as sensitive as raw eggs has to be sent by special transport. There are recorders attached to it, which sense temperature, humidity and vibrations or shock. We defined acceptable thresholds for all of these, and none have been exceeded, which is a good result. The specialists from Glasgow unpacked their baby themselves and brought it into our Glass 100 room with our help.
For scientists Mike and Christian, this is a very important day. After 10 years' work, they now want to deliver the optical bench to the satellite builders. The Milde Pathfinder spacecraft is scheduled to fly in 2015, and this component is a key technology of the mission, a mission like no other before it. It is designed to clear the way for measuring gravitational waves in space. That's why the European Space Agency ESA and Astrium have very strict requirements.
We don't just have the job of continuing the construction of this optical instrument in our clean room and then deliver it. We also have to ensure that the level of precision which is demanded from this instrument is maintained throughout the final product.
The Astrium technicians keep a close watch on the final test routines performed by Mike and Christian, which prove that the optical bench really is capable of fulfilling all requirements. The delicate glass ceramic structure houses 4 separate interferometers. The path of the laser light is crucial. The scientists can tell everything about the optical bench just by measuring the position of the laser beams.
It was important for us to develop this beam position measuring device and to be able to use it at every stage of the testing to make sure everything was still okay, to make sure that we understood where things were, to make sure we understood that things would be where we thought they were in the future. So it was a very important monitoring tool, and it was very important for making sure that we delivered what we said we were delivering.
Just how well the system works was unintentionally proved by the 2 scientists. The test data showed some results which were unexpected. The reason was quickly found. Some of the screws fixing the base plate had been tightened when it had been resting in a slightly different position.
What we found today is that when we de-stressed these pieces, there was a very small movement of one of the base plate, probably in a slight bending motion. This shows up on some of the photodiodes. And the reason it shows up on some of the photodiodes is because the beam that gets to these photodiodes has traversed the bench at least once, probably more than once. And so it's had a chance to be reflected up and up and up by this tiny margin, say less than 10 microns, so a fifth of the diameter of human hair. The alignment of the bench is so precise and so well monitored that we can measure these kind of misalignments.
The optical bench successfully has been proven to work correctly. In a conference call with representatives of space agencies from the UK and Europe, the scientists could then formally hand over the masterpiece to Astrium in Friedrichshafen.
I think the next thing that happens here is we'll probably have a beer. And then I think after that, the optical bench will be integrated. It'll have its side slabs put on and a top plate. It'll have dummy test masses put on, and it will get integrated into more of the core assembly. The people at Astrium, the engineers at Astrium and the technicians will gradually build the optical bench up, because the optical bench is right in the middle of Pathfinder. It will become something other than the optical bench. It will grow into the core assembly.
Today we got the heart of Pathfinder, the optical bench. We have long years of work and tests behind us. It is now the job of my small team of engineers and mechanics to continue this high-precision work.